This is the parabolic motion of an object with the starting velocity v. The angle between the direction of the moving of the projected object and the horizontal direction, is theta. So we know the velocity on the horizon, Vx, is v times cosine theta, and the vertical velocity, the velocity on the vertical direction upward, is vy equals v times sine theta, and this is the horizontal speed. The horizontal speed will be steady, and the vertical speed, velocity vy will change with the acceleration minus g, because it is moving upward, and the acceleration is downward. So the movement of this projected object could be separated into two movements. One is on the horizon, and one is vertical. And these two movements are independent of each other. So we'll have this diagram with the x-axis as the movement on the horizon, and the y-axis is the movement on the vertical direction. And the vertical, and this is the parabolic motion, and the object, the starting velocity on the vertical direction, vy, is vy, and when it arrives at the highest point, the velocity on the horizon on the vertical direction will be 0. Then we can get the time to arrive at the highest point, that is vy over g. And the object position, the position x on the horizon direction, horizontal direction, is vx, the steady speed on the horizon, times t times unit vector I. That is the distance traveled on the horizon. This is a vector. From at the point P, we can get the x, px, and py. Py is on the vertical, is the distance traveled on the vertical, is the position on the vertical line, and it is a vector. So we have a unit vector j, and the integral from time 0 to time t of the velocity on the vertical direction, vy minus gt times dt. And this is the position on the y direction. At point A, when the object arrives at the highest point, the time traveled, the time spent is Vy over g, and the distance traveled on the vertical direction will be at the position of the object on the vertical direction, Pyh. H is the point on the x-axis when the object is at the highest point. YH is the highest point. So that is we insert Vy over g into this, and we will get Vy squared over 2g, j roof. And when the object falls on the ground, the time will be the time spent will be 2 Vy over g. Will be twice the time, twice the time spent to arrive at the highest point. So this is symmetrical. The time spent to arrive at the highest point and the time spent to reach the ground is the same. So when the object falls on the ground, the time will be twice the time spent to arrive at the highest point. That is 2 Vy over g, and we put 2 Vy over g into this function. Well, we will get 0. The position on the vertical direction will be 0, and that is obvious by looking at this diagram. So it is clear that we learned from this parabolic motion of this object, that the movement on the horizon and the movement on the vertical direction are independent of each other.